everyone. How are you, my dear children? Hope you all are safe and fine. Today we are going to discuss the physical significance of electric field. This is a little bit difficult one, very important concept. It is there in NCERT. So I am trying my best to make you understand this beautiful concept. And in NCERT also they have explained beautifully. See what is physical significance of electric field. Till now what we have studied about the electric force. That means when there is a system of charge, that means some charge distribution like this. Suppose here Q1, Q2, Q3, Q4. Suppose this is the system of charge is given over here, and another charge Q is over here. Okay, so we can find out the force on this charge Q due to all these charges Q1, Q2, Q3 and Q4. How? By using Coulomb's law and superposition principle. But Faraday has introduced the concept of electric field. In electrostatics, electric field, these lines are there in NCERT book. Electric field is convenient, okay, is convenient but not necessary. Not necessary because we know electrostatic force. Then what is the need of this electric field, that we are going to study. See this bad handwriting, please don't mind because there is some lag. So that's why this handwriting I am getting. Okay. So we know that force is dependent on test charge. This thing we have already studied. Dependent on test charge. But electric field is independent of the test charge. But electric field E is independent of test charge. Major difference, see, independent of test charge. Okay. So this electric field E is the characteristic of the system of charges. That means it is unique for a given system of charges. Suppose this Q1 is at rest, okay, and it is at the distance R from this charge Q. Okay, then what is the electric field? Tell me, what will be the electric field? Electric field E will be 1 by 4 pi epsilon naught Q1 by R square. When this Q1 is at rest, this thing we have studied. If this Q1 is in motion, then what will happen? Let us see. If Q1 is in motion, that means its position will change with time. So that means this distance R, it will also change with time. That means it is now time dependent field. Got it? It is now time dependent field. Time dependent field. That means your R, this R, distance R is now function of time. It is dependent on time. Okay, let us see how it is. Let me explain. See children, so this is your Q1 charge. I am just taking this Q1 charge right now. Okay, and this is your Q charge, and this is the distance R. Now Q1 is in motion. That means suppose this Q1 now move to this place. Okay, now suppose this Q1 is moving to the, one second children, pen is not working, there is some problem. Okay, now suppose this Q1 is, so this Q1 now moves to this place. Okay, let this distance is r. Now this is the new position of your q1. Now when q1 move to this place, that means your this r increases. R is now increasing. So what is the distance now? Now the total distance from this q charge will be r plus dr. So if r increases, that means your electric field will decrease. We know that just now we have seen electric field is equal to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught q1 by r square. So when this r increases, so your electric field will change. So when the electric field will change, so definitely your force will also change. How? Because we know electric field is equal to F by Q. So that means F is equal to QE. So when electric field is changing, that means F also change. This will also change when electric field changes. This thing we have understood. Okay. So that means when we are moving this Q1 charge to this place, that means your force changes. This change in force will not be immediately felt by this Q. You can't see the change in force for this charge Q. Let us try to understand. We know signal or information can go from one point to another with the speed of light, c. Okay? So the effect of any motion on this charge, on Q1, okay? The effect of any motion of this Q1 will not be immediately experienced by this Q. It cannot arise instantaneously because it will take some time. So when there will be some change in force on Q1, immediately there will not be any change on the force on this charge Q. There will be some time delay. Let us try to understand how much this delay will be. There will be time delay. See, the time delay t will be how much? Total distance divided by the speed of the light. So this is the time delay. Okay. So to explain this time delay, we have to use the concept of electric field. Okay. Now, this Q1 is an accelerated charge. This is an accelerated charge. Remember this. Okay. You have to listen to this lecture very carefully. Okay. So much of concept, no such derivations. Okay. So Q1 is accelerated charge. So this accelerated charge will produce electromagnetic waves. This accelerated charge will produce electromagnetic waves. So accelerated charge will produce now electromagnetic waves. Electromagnetic waves. Okay. These electromagnetic waves will propagate or travel with the speed of light c. And when it reaches this, it will propagate like this. And when it reaches this charge Q, then only this cause, or you can say the change, you can see the change on the force on Q. That means now Q can experience the effect. Now Q can experience the change in force. What happens with the Q1? Okay. So let me clear the board. So that means Q can experience the effect now. Okay. This Q charge can now experience the effect. It can experience the effect but with time delay. Okay. The motion of field elegantly accounts for the time delay. The motion of the field elegantly accounts for the time delay. This beautiful line is there in NCERT. One more thing, children. The electromagnetic waves means there will be electric field and magnetic field, both electric and magnetic field. Okay? Electromagnetic waves means both the fields are there. These two fields, they can transport energy. They have an independent, they can transport energy. They can transport energy. They have an independent dynamics of their own. That means they have their own law. That means they evolve according to the laws of their own. Now let us understand. Suppose this is a plane surface. Okay. Now a small light plastic ball is over here. Very light, tiny plastic ball is over here now. Let us try to understand this concept, what is there in NCERT book. Okay. Now a huge stone I have thrown like this. So this, when I throw this stone, is it going to affect the plastic ball? No. Now same thing, now we'll keep it in water. Now still water is over here. Same very light plastic ball is over here. Now I have thrown the stone like this. Then what we'll observe? We'll observe this ball will move like this. There will be change in motion in the ball. Why? That means when I throw this ball, a wave is generated. A wave is generated. And this wave travels, okay, and reaches the ball. And when it reaches the ball, now this ball will also experience a motion. You can say oscillatory motion over here. Similarly, in this case, so a Q1 charge is over here. This is your Q1 charge, okay, and this is your Q charge, and we have changed the position of this Q1, okay, with dr distance, and this is your R. So here also, like in this case, a electromagnetic wave generates. A electromagnetic wave generates and travels. Okay, that means here also, like how water is over here, then only this wave travels and it disturbs the ball. So similarly, the similar concept, there is something over here, okay, due to which your wave propagates and change, there is the change in effect experienced by the Q. And what is that? That is your electric field, children. That is your electric field. Understood? Do you understand anything? That means now energy transports from this place to this place. So now the change in force over here can be experienced by this charge, capital charge Q. Now another important thing. If, see these children, if this charge is not over here, Q is absent, okay, it is absent. Can you just tell me, will this absence of this charge Q will stop the generation of the electromagnetic wave over here? No, still there will be some generation of electromagnetic waves. That means transport of energy will be there. That means electric field has to be there. So for the electric field, for the concept of electric field, this electric field is a physical thing only. So for this electric field, this charge is not at all responsible. So it is not mandatory. But if this Q charge is not over here, can this electric force will be there? Because we know electric force will be how much? Mathematical expression what we have studied? 1/4 pi epsilon r. In this case, it will be Q1 Q by R square. But what is the electric field over here? Can I write over here? Electric field. So electric field is how much? 1 by 4 pi epsilon naught Q1 by R square. See, if the capital Q charge is not there, still there will be electric field. But if the capital charge is not there, then there will be no electrostatic force. So that is the beautiful concept of electric field. So that's why this electric field now became the central concept in physics, which was introduced by Faraday. Okay, even in higher class, one more thing children you will study. If there is no charge also, still there will be field according to Maxwell equations. That you are going to study in higher classes of physics. Okay, hope you have understood this lecture. What is there in NCERT book is a very good concept but difficult to understand. I have tried my best to make you understand this physical significance of electric field. Hope this lecture will help you. Thank you for watching children and take care.